Hey everyone, tonight I'm doing LeetCode challenge number 2125 called Number of Laser Beams in a Bank. In this challenge, the description here tells us anti-theft security devices are activated inside a bank. You are given a binary string array called bank, which represents the floor plan of the bank. And basically each element in the array, bank at I, represents a row in the bank and consists of zeros and ones. 0 means that the cell is empty, while 1 means that the cell has a security device. There's one laser beam between any two security devices if both conditions are met. The two devices have to be located on two different rows, and for each row there are no security devices in the row that's in between them. So for example, down here, this device cannot connect to this one because there are devices here on a row that's in between them. Laser beams are independent. One beam does not interfere with or join another, and it asks you to return the total number of laser beams in the bank. So let's look at this first example to understand this a bit better. Down here is the input. So this is an array with our binary strings. This one right here represents the first row. So you have empty cell, device, device, empty cell, device. The second row has no devices, so these ones have to connect their beam down to this third row right here. And in the first row we have 3, none here, and 2 here. So notice that 3 and 2 gives us a total of 6. So you want to notice that that's simply multiplication, right? They're each connecting one time to each device on each row, so we need to multiply to find the number. So 6 beams here between 3 and 2, 2 and 1 between the final two rows is 2 more possible beams. So for first example, we would get a total of 8 beams. So the strategy here needs to be to iterate through each element, each row, and count the number of ones and keep track of how many devices essentially are on each row. And then between the ones that have devices, you want to multiply 3 times 2 and store that, and then multiply 2 times 1 and sum that all up to get the total number of laser beams. So getting into coding this out, I'm going to set up an array here to keep track of the number of devices on each row. Then I'm going to iterate through the input array. Now I need to find the number of ones in each row. A couple different ways we could do this. I'll call the variable number of lasers, and I'll do it like this. I'm not sure if this is the fastest or most optimal way to do this, but this is the way that comes to mind right now. So I'm taking the row, the binary string, I'm splitting it into an array, and then I'm going to filter that to include only the elements that are ones. And so now that's down to an array of ones only, so I can do, I can get the length of that array, and that will tell me how many ones are in each row. Now I only want to add this number to our devices array if the number is not 0. So for example, this row right here, that number would be 0. I don't want to include that in the devices array because I don't want to end up multiplying 3 times 0 and 0 times 2. That would not give me the correct answer. So I'm going to say if num of lasers does not equal 0, then I can add that to the devices array. Okay, so before I go on, I just want to double check that that part is working correctly and giving me what I expect. This should give me the devices array, should be 3 elements, 3, 2, 1, because we skipped this row right here, which was the 0. And looks like that's working so far, so that's good. Now the rest of this should be pretty easy. So I'm going to need a variable to sum up the number of beams. I'll just call that beams and set it equal to 0. And now I want to iterate through the device array. And I'm going to do less than devices.length minus 1 because I only want to go I up to the second to last element because I'm going to be multiplying up to the element after it. And then we're going to do beams plus equals devices at I times devices at I plus 1. So this will multiply 3 times 2 and add that to the number of beams, multiply 2 times 1 and add that to the number of beams. And I'll hit return beams. And the alignment got a little messed up here. I'll tab that over. Okay, think that looks good so far. I'll check with the test cases. Looks good, and I'll submit. All right, and looks like that is working. Now that may not be the most optimal solution. There's probably some ways that you could speed this up a bit, especially I'm thinking this line right here is maybe not the fastest way to find the number of ones. So it would be good to try to refactor that and come up with a slightly more optimized way of doing this, but this is the initial way that came to mind as I worked through this challenge tonight. So I hope you found this video helpful, and let me know if you have any questions.